In this video, I'm going to talk about sequence and series. After watching the video, students should be able to use the formula for the sum of a geometric series in solving problems. The formula is sum of first n term equals a times r power n minus 1 divided by r minus 1, where a is the first term in the series and r is the common ratio. Let's proceed to the question. Question 1. At the beginning of this year, Mr. Lim and Mr. Tan deposited Rm 10,000 and Rm 2,000 respectively in a bank. They received an interest of 4% per annum. Mr. Lim does not make any additional deposit nor withdraw, whereas Mr. Tan continues to deposit Rm 2,000 at the beginning of each of the subsequent years without any withdrawal. Question A. Calculate the total saving of Mr. Lim at the end of 10th year. B. Calculate the total saving of Mr. Tan at the end of 10th year. Question A. At the beginning of the first year, Mr. Lim deposit Rm 10,000. Then at the end of the first year, the amount in the bank will increase because of the interest. So after the interest, the amount in the bank now should be 10,000, that is the initial deposit plus the interest. The interest is 4% based on the amount in the bank, that is 10,000. Then now we factorize the 10,000 because this 10,000 refer to the same amount of money. Then after factorize the 10,000, this one is 1 plus 0.04 becomes 1.04. Then this amount of money will be transferred to the second year. So at the beginning of the second year, this amount of money is in the bank. Then after that, at the end of the second year, now the amount of money in the bank will increase because of the interest. Then at the end of the second year, the amount in the bank is this one. This is the amount of money that transfer from the end of the first year. Then this is the interest based on the amount of money it is in the bank for the second year. That is 10,000 times 1.04. Then now we do the factorize this one because 10,000 times 1.04 refer to the same money. So when we factorize, this is 1, this is 0.4, we will get 1.04. 1.04 times 1.04, then we get 1.04 power 2. Then this amount of money will be carried forward to the beginning of the third year. Then after that, at the end of the third year, now the amount of money in the bank will increase again because of the interest. The interest received is based on the amount of money in the bank at that time. So now at the end of the third year, the amount of money in the bank is this one. This is the amount of money carried forward from the second year. So now after combined with the interest, now we factorize the money. So this amount of money is the same. So we factorize. So after that, this is 1. Here you have 0.04. becomes 1.04. So 1.04 times 1.04 power 2, then we get 1.04 power 3. Now we try to combine the amount of money for each of the year together to see how the number change each year. So we can see that at the end of first year, the amount of money is 10,000 times 1.04. For the second year, 10,000 times 1.04 power 2. Third year, 10,000 times 1.04 power 3. So from the change of the amount of money in the bank for these 3 years, now I can predict that at the end of the fourth year, the amount of money in the bank is 10,000 times 1.04 power 4. Then when we continue until the end year, so I can predict that the amount of money in the bank is 10,000 times 1.04 power n. So therefore, now I can answer the question that the total saving at the end of 10 years is 10,000 times 1.04 power 10. That is equal to 14,802.44 ringgit. Question number B. At the beginning of first year, Mr. Tan deposit 2,000. Then at the end of first year, the amount of money in the bank will increase because of the interest. So now, the amount in the bank after receive the interest is 2,000. 2,000 is the original deposit at the beginning of the year plus the interest. Interest is 4% based on the 2,000 here. So now we factorize the 2,000 because this 2,000 is the same money. So we factorize. Now this one is 1 plus 0.04. We get 2,000 times 1.04. So this amount of money will be carried forward to the beginning of the second year. Then at the beginning of the second year, Mr. Tan will deposit another 2,000. So in the second year, the total amount of money in the bank is this one. Then up to the end of the second year, Mr. Tan received the interest. The interest is 4% based on the amount of money in the bank during the second year. Then now we can see that this amount of money actually is the same money. So now we factorize this money out. Then now this one is 1 plus 0.04. It is equal to 1.04. Then after that, again we expand the 1.04. We will get 2,000 times 1.04 power 2 plus 2,000 times 1.04. So this is the amount of money at the end of second year after receive the interest. So this money will be carried forward to the third year. At the beginning of third year, this amount of money will carry forward from the second year. Then at the beginning of third year, Mr. Tan deposit another new 2,000. So during the third year, this is the amount of money in the bank. Then at the end of the third year, Mr. Tan received the interest, 4% based on the amount of money in the bank during the year number 3. So now we can see that this amount of money and this amount of money is the same money. So we factorize this amount of money. We factorize out. Then here we have 1 plus 0.04. Then we get 1.04. Then after that, this 1.04 will expand to each term here. Then we will get 1.04 power 3, 1.04 power 2, and 1.04. Now up to year number 3, we can already see how the number change from year 1, year 2, and year 3. Now we combine the amount of money for each year from year 1 to year 3. We combine together so that we can see how the number change. So for the first year, 2000 times 1.04. For year 2, 2000 times 1.04 power 2 plus 2000 times 1.04 power 1. For year 3, 2000 times 1.04 power 3 plus 2000 times 1.04 power 2 plus 2000 times 1.04 power 1. Now, based on the change of the number here, I can predict that at the end of 4th year, the amount of money in the bank is 2000 times 1.04 power 4 plus 2000 times 1.04 power 3 followed by power 2 followed by power 1. And until when I continue, at the end of n year, I can predict that the amount of money in the bank should be 2000 times 1.04 power n followed by 2000 times 1.04 power n minus 1, then continue up to power 2, continue up to power 1. So from here, we can see that this series is a geometry series. So, but now the only thing is n is in front, power 1 is at the end. So now we can rearrange the series becomes 2000 times 1.04 power 1, power 2, power 3 up to power n. So this is very clear that this one is geometry series. With the first term is 2000 times 1.04 and common ratio is 1.04. So therefore, to calculate the total amount of money, I can use the formula of sum for geometric series. That is A is 2000 times 1.04 times R power n. R is 1.04 power n minus 1 divided by R minus 1, that is 1.04 minus 1. So when I calculate and simplify, I find that it is 52,000 times 1.04 power n minus 1. So therefore, I can answer the question that the total saving at the end of 10th year, that is 52000 times 1.04 power 10 minus 1, then it is equal to 24,972.70. Now we proceed to the second question. A savings scheme pays 5% per annum compound interest. A deposit of Rm100 is invested in this scheme at the start of each year. Find the amount in the scheme at the start of the 40th year after the annual deposit has been made. In the first question, the time asked in the question is at the end of the year. But in this question, the time is the start of each year. So when answering the question, we have to read very careful in the question whether the time given is at the end of the year or at the beginning of the year. So in this question, at the beginning of the year. So for the first year, at the beginning of the first year, 100 ringgit is invested. So this 100 ringgit invested will not given any interest at the beginning of the year. The interest will be given after 1 year. That is at the beginning of the second year. So when the beginning of the second year, we will have 3 kinds of money. First one is during the beginning of the second year, we will deposit another 100 ringgit. Then another one is 100 ringgit, which is carried forward from the first year. Then another one is the interest based on the amount of money invested in the first year. So we have three kinds of money. One is the new deposit, one is the deposit from the first year, one is the interest. So now we are going to do the factorization. So when doing the factorization, even though here you can see there are three 100 ringgit, when doing the factorization, we won't involve the new deposit 100 ringgit. We are going to factorize the 100 ringgit that is deposit during the first year and the interest, because interest is 5% based on the year 1 deposit. So this 100 ringgit and this 100 ringgit, actually that is the same money. That is the 100 ringgit in the first year deposit. This one also the 100 ringgit in the first year deposit. So when we do the factorization, only involve this 100. So when doing factorization, we take out the 100. Here we have 1. Here we have 0.05. Then after that, we get 1.05. So this total amount is the total investment during the second year. And this money will be carried forward to the year 3. So at the beginning of year 3, we will receive three kinds of money. First one is the year 3 deposit, that is 100 ringgit. Then we will also receive the money that is carried forward from the second year. And at the same time, we also receive the interest that is received based on the total investment in second year. So now we have this amount of money. So now we are going to do the factorization. So we can see that this money and this money is the second year total amount of money. So means when we do factorization, we factorize this same money come out. So here we get 1, here we get 0.05, then after that we get 1.05. So now after factorize, now we expand it back. Now we will get 100 times 1.05. So here 100 times 1.05 power 2. And this total amount of money is the total investment during the third year and will be carried forward to the fourth year. Now, based on the calculation of year 1, year 2, and year 3, we can see how the number change. So now we put them together in order to see it clear. So this is the year 1 investment 100, then year 2 100 plus 100 times 1.05, year 3 100 plus 100 times 1.05 plus 100 times 1.05 power 2. So based on the change of this value, I can predict that at the start of fourth year, the total investment is 100 plus 100 times 1.05 plus 100 times 1.05 power 2 plus 100 times 1.05 power 3. Then until we continue up to n year. So I can predict that at the start of n year, the total investment is from 100 plus 100 times 1.05 power 1, followed by power 2, followed by power 3, up to power n minus 1. Because you can see the number here, when year 3, the last power is power 2. So sure, when year end, the last power is n minus 1. Now from this series, I can see that actually this is a geometric series. So means in this case, I can use the formula sum of first n term of geometric series to find the total amount. That is a times r power n minus 1 divided by r minus 1, where a is 100 and r is 1.05. So when I simplify this part, I will get 2000. So now I can answer the question that start of 40th years, I just substitute n with 40. Then when I press calculator, then I'll get the answer that is 12,079.98. Now we proceed to the third question. City borrows 300,000 from a bank which charges her 13% interest per annum on the outstanding amount due at the end of each year. She repays the bank in equal yearly installments of P ringgit. Find the expression for the amount due after n years. So in this case, the interest will be charged at the end of the year. So at the end of the first year, the total outstanding becomes the original outstanding, that is 300,000, plus the interest. The interest is based on the 300,000 minus the installment paid by City. So now we are going to do the factorization. So this 300,000 is the same amount of money. So when we take out 300,000, here we have 1 plus 0.13, then we get 1.13. So this total amount will be carried forward to the second year, and this is the total outstanding during the second year. Then until the end of the second year, the new outstanding is the total outstanding during the second year plus the interest charge for the second year outstanding minus the second installment repaid by City. So now we can see that this amount of money and this amount of money, that is referred to the same money. So we factorize this money out. Then here we get 1 and 0.13. Then we get 1.13. Then we expand the 1.13. We get 1.13 power 2. Then P times 1.13. So this is the amount of total outstanding at the end of second year, and this will be carried forward to the year 3. Then this is the total outstanding of year 3. Then at the end of year 3, so now the total outstanding becomes the original outstanding that carry forward from year 2 plus the interest charge and minus the third installment. So now we are going to factorize. We can see that this amount of money and this amount of money is the same. So when we factorize, then we will get 1 plus 0.13 and we get 1.13. Then after that, we expand 1.13. We will get 1.13 power 3, 1.13 power 2. Here, P times 1.13. After doing the calculation for year 1, year 2, and year 3, so now actually we can see how the number changed. So now we group them together in order to see how the numbers change easily. So this is the first year, 300,000 times 1.13 minus P. Year 2, 300,000 times 1.13 power 2 minus P times 1.13 minus P. Then year 3, 300,000 times 1.13 power 3 minus P times 1.13 power 2 minus P times 1.13 minus P. So from this series, I can predict that at the end of the 4th year, the total outstanding becomes 300,000 times 1.13 power 4 minus P times 1.13 power 3 minus P times 1.13 power 2, then power 1, then up to minus P. Then when I continue up to n years, then I can predict that the total outstanding will be 300,000 times 1.13 power n, then minus P times 1.13 power n minus 1, and continue up to P times 1.13 power 1, then minus P. Now when we look at the total outstanding of the n years, so actually you can see that this one is a geometric series. The only thing is this one is minus. So now first we factorize the minus. So now we can see inside here that is the sum of the series. And I rearrange so that we start from P times 1.13 power 1, power 2, and up to power n minus 1. So this part of series, actually that is the geometric series. So means I can use the formula that is sum of first n term to calculate this part. So now by using the formula, this is A and the common ratio is 1.13. So when I simplify this part, I will get 100p times 1.13 power n minus 1 divided by 13. So this is the expression for the total outstanding amount after n years. Now this is the end of the lesson. From the lesson just now, you have learned how to find the expression of the n term to solve the problems of geometric series. I hope you keep on learning and do more practice in order to master the topic. If you have any question, let me know in Teacher Eileen Maths group. I hope to see you soon. Bye!